Welcome to TalkCast and to episode 106, which is part 2 of chapter 4 of The Fabric of Reality, Criteria for Reality. And in the last part, we went through a refutation of solipsism and the various other, what one might call, metaphysical theories about ultimate reality. Namely that realism might not be true because perhaps it's all a dream going on in your head, or perhaps it's a simulation going on in a computer, or perhaps it's the machinations of an evil demon. Whatever the case might be, realism might not be false. How can we rule this out? And we were talking about the fact that no scientific experiment can falsify that kind of theory, that kind of strange claim that reality itself might be utterly different from what we experience or what our science is telling us the truth of the matter happens to be. And that all of our supposed good explanations are actually bad explanations based upon the fact that ultimate reality is all going on in the mind of a dreamer. It seems we can't rule that out logically. And we can't rule that out scientifically either. So what can we do? Well, what we can do is what we did do in the last episode. And in The Fabric of Reality, David goes through a refutation. Not a scientific falsification, not a logical disproof, but a philosophical refutation. An explanation that these explanations are bad explanations. And where we finished was with David saying in The Fabric of Reality, and I'll quote again, quote, "So we can continue, reassured with common sense realism and the pursuit of explanations by scientific methods. But in the light of this conclusion, what can we say about the arguments that made solipsism and its relatives superficially plausible? Namely, that they could neither be proved false nor ruled out by experiment. What is the status of those arguments now? If we have neither proved solipsism false nor ruled it out by experiment, what have we done?" And David goes on to say, there is an assumption built into this question. It is that theories can be classified in a hierarchy, mathematical to scientific to philosophical, of decreasing intrinsic reliability. Many people take the existence of this hierarchy for granted, despite the fact that these judgments of comparative reliability depend entirely on philosophical arguments that classify themselves as quite unreliable. In fact, the idea of this hierarchy is a cousin of the reductionist mistake I discussed in Chapter 1. Namely, the theory that microscopic laws and phenomena are more fundamental than emergent ones. Pausing there, my reflection. We learn this in school. And in fact, mathematics teachers are quite proud of the fact that they can say to the other teachers of other subjects, we have privileged access to teaching certainty, to teaching mathematical, logical certainty in our classes. And they really take this seriously. I suppose they get it from their lecturers as well. So it bleeds into culture because it's kind of there in the schooling system that mathematics is taught as being absolutely certain on a firm foundation. But of course, this very claim that mathematics is certain, that it is built upon a firm foundation, an infallible way of getting at the truth, that very claim is itself a philosophical argument. It's false. It turns out that it's false. But the mere fact that that anyone would be trying to make that argument should reconsider the fact that they're not getting there by a mathematical proof, which is supposedly the only way to get to absolutely certain truth. So if the argument for mathematics has the only privileged access to absolutely certain truth, but that argument itself is based upon a philosophical claim, which itself, supposedly, is nothing but a mere matter of opinion, we've got a problem. And of course, in the David Deutsch fallibilist worldview, we're going to do away with all of that, and we're simply going to regard each of the different domains of our inquiry, call them what you want, mathematical, scientific, philosophical, as all on equal footing in a sense, all part of an interconnected web of knowledge, an interconnected web of fallible guesses about the nature of reality. So let's go on to see what David says next about this. Quote, "The same assumption occurs in inductivism, which supposes that we can be absolutely certain of the conclusions of mathematical arguments because they are deductive, reasonably sure of scientific arguments because they are inductive, and forever undecided about philosophical arguments, which it sees as little more than matters of taste. End quote. And isn't that the truth? I mean, not only do we pick that up in school, it's something that I think almost everyone lives with all the time, unless they've encountered the work of Popper and Deutsch and associated ideas. But you don't have to step very far outside of the Popperian worldview or the worldview presented in The Fabric of Reality, The Beginning of Infinity, before you get this as simply common sense. This idea that, as David says there in that paragraph, mathematical arguments are certain because they're deductive. So you can be sure of them. And you can be almost sure of scientific arguments because they're inductive. And as for philosophy, well, that's just a mere matter of opinion, more or less. So I'm skipping about a paragraph, and David goes on to say, quote, "The rejection of mere explanations on the grounds that they are not justified by any ultimate explanation inevitably propels one into futile searches for an ultimate source of justification. There is no such source, nor is there that hierarchy of reliability from mathematical to scientific to philosophical arguments. Some philosophical arguments, including the argument against solipsism, are far more compelling than any scientific argument. Indeed, every scientific argument assumes the falsity not only of solipsism, but also of other philosophical theories, including any number of variants of solipsism that might contradict specific parts of the scientific argument. I shall also show in Chapter 10 that even purely mathematical arguments derive their reliability from the physical and philosophical theories that underpin them, and therefore they cannot, after all, yield absolute certainty. Having embraced realism, we are continually faced with decisions as to whether entities referred to in competing explanations are real or not. Deciding that they are not real, as we did in the case of the angel theory of planetary motion, is equivalent to rejecting the corresponding explanation. Thus, in searching for and judging explanations, we need more than just a refutation of solipsism. We need to develop reasons for accepting or rejecting the existence of entities that may appear in contending theories. In other words, we need a criterion for reality. We should not, of course, expect to find a final or infallible criterion. Our judgments of what is or is not real always depend on the various explanations that are available to us, and sometimes change as our explanations improve. Just pausing there, my reflection. So what David is going to come to here in The Fabric of Reality is that our criterion for reality is whether or not an entity kicks back, and we'll have more to say about this. This is Dr. Johnson's criterion. And whether something kicks back is about whether it behaves autonomously, unpredictably, in a complex way, in a way that would require, if it was going to be an illusion, computationally highly complex in order to simulate, in order to give us the appearance of that thing. But later, of course, in The Beginning of Infinity, I think we get a more parsimonious version of this, which entails all of those other ways in which we explain whether a thing is real or not, whether a thing exists or not, where we say a thing is real or a thing exists to the extent that it appears in our best explanations of reality, if and only if it appears in those explanations. So I'll pick it up where David says, quote, "Not only do explanations change, but our criteria and ideas about what should count as an explanation are gradually changing, improving too. So the list of acceptable modes of explanation will always be open-ended, and consequently, the list of acceptable criteria for reality must be open-ended too. But what is it about an explanation, given that, for whatever reasons, we find it satisfactory, that should make us classify some things as real and other things as illusory or imaginary?" James Boswell relates in his Life of Johnson how he and Dr. Johnson were discussing Bishop Berkeley's solipsistic theory of the non-existence of the material world. Boswell remarked that although no one believed the theory, no one could refute it either. Dr. Johnson kicked a large rock and said, as his foot rebounded, "I refute it thus." Dr. Johnson's point was that Berkeley's denial of the rock's existence is incompatible with finding an explanation of the rebound that he himself felt. Solipsism cannot accommodate any explanation of why that experiment, or any experiment, should have one outcome rather than another. To explain the effect that the rock had on him, Dr. Johnson was forced to take a position on the nature of rocks. Were they part of an autonomous external reality, or were they figments of his imagination? In the latter case, he would have to conclude that his imagination was itself a vast, complex, autonomous universe. Pausing there, my reflection. So Bishop Berkeley, or Bishop Berkeley, however we pronounce it, he had this vision of idealism. Idealism meaning that what is apparently happening in external reality isn't really, it's just all ideas. It's going on inside your head. But what Johnson would say about that, what Dr. Johnson would say about that, is if you kick a rock and reliably the same experience is happening again and again, you're effectively doing a scientific experiment in order to test theories about what happens when you kick rocks and your foot continues to rebound, why should it have this consistent character? Why should there be this autonomous way in which your imagination behaves consistently over time? You would have to concede that your imagination is itself this extremely complex thing which behaves according to physical laws that one can discover. And as we say, that means that your idealism, Bishop Berkeley's idealism, this idea of solipsism or whatever you like, is nothing but realism, the claim that there really is an external, autonomous reality which you cannot simply imagine into existence. You cannot imagine into existence the behavior of different things, but rather you have to go out into the world and investigate things and to find out how they're going to behave, namely by kicking them. If it was all just in your imagination, we should expect that each time you kick the rock, something different might happen. Sometimes your foot might rebound. Sometimes it might go through it. Sometimes the rock might disappear. Sometimes the rock might turn into a rabbit and so on, and ad infinitum. But the fact that the rock behaves in a predictable way, and the fact that we can learn about the properties of rocks, and so on and so forth, for every other object in our external reality, means that it can't just all be in your imagination. Or if you postulate that, all you're saying is that your imagination is equally as complex and subject to physical laws as real physical reality is. And so you are just saying that realism is true, plus the assumption that you're dreaming that physical reality into existence. So it's a needless philosophical assumption. David goes on to say after a paragraph that I'm skipping, quote, "But Dr. Johnson's idea is more than just a refutation of solipsism. It also illustrates the criterion for reality that is used in science. Namely, if something can kick back, it exists. Kicking back here does not necessarily mean that the alleged object is responding to being kicked, to being physically affected as Dr. Johnson's rock was. It is enough that when we kick something, the object affects us in ways that require independent explanation. For example, Galileo had no means of affecting planets, but he could affect the light that came from them. His equivalent of kicking the rock was refracting that light from the lenses of his telescopes and eyes. That light responded by kicking his retina back. The way it kicked back allowed him to conclude not only that the light was real, but that the heliocentric planetary motions required to explain the patterns in which the light arrived were also real. By the way, Dr. Johnson did not directly kick the rock either. A person is a mind, not a body. The Dr. Johnson who performed the experiment was a mind, and that mind directly kicked only some nerves, which transmitted signals to the muscles which propelled his foot towards the rock. Shortly afterwards, Dr. Johnson perceived being kicked back by the rock, but again only indirectly, after the impact had set up a pressure pattern in his shoe and then in his skin, and had then led to electrical impulses in his nerves and so forth. Dr. Johnson's mind, like Galileo's and everyone else's, kicked nerves and was kicked back by nerves and inferred the existence and properties of reality from those interactions alone. What Dr. Johnson was entitled to infer about reality depends on how he could best explain what had happened." Just pausing there, my reflection. So this concept of kicking back, obviously it's metaphorical in almost all situations, except when you're explicitly kicking rocks. But even then, as David says, it's not really you that are kicking the rock, you are kicking the nerves inside of your brain. All that aside, what the kickback means is that you are getting evidence, feedback from the external physical reality around you. And that external physical reality is not merely bending to your will. It is sometimes behaving in completely unpredictable ways, as Galileo's discovery through his telescope was. I'm not sure if he hypothesized that there would be, definitely, moons going around Jupiter, but when he saw that, that was an unexpected kickback from reality. Galileo, by the way, was the first one to discover moons orbiting Jupiter. Okay, so skipping a quite substantial part of the book now, a couple of pages, and I'm picking it up where David says, quote, "It is not how hard something kicks back that makes the theory of its existence compelling. What matters is its role in the explanations that such a theory provides. I have given examples from physics where very tiny kicks lead us to momentous conclusions about reality. because we have no other explanation. The converse can also happen. If there is no clear-cut winner among the contending explanations, then even a very powerful kick may not convince us that the supposed source has independent reality. For example, you may one day see terrifying monsters attacking you, and then wake up. If the explanation that they originated within your own mind seems adequate, it would be irrational for you to conclude that there really are such monsters out there. If you feel a sudden pain in your shoulder as you walk down a busy street and look around and see nothing to explain it, you may wonder whether the pain was caused by an unconscious part of your own mind, or by your body, or by something outside. You may consider it possible that a hidden prankster has shot you with an airgun, yet come to no conclusion as to the reality of such a person. But if you then saw an airgun pellet rolling away on the pavement, you might conclude that no explanation solved the problem as well as the airgun explanation, in which case you would adopt it. In other words, you would tentatively infer the existence of a person you had not seen and might never see, just because of that person's role in the best explanation available to you. Pausing there, my reflection. Now, isn't that a wonderful little example? As I have often said on this podcast, getting it straight from David Deutsch, we are usually in science explaining the seen in terms of the unseen. This is what science is all about. Almost every single interesting phenomena in modern science is about explaining what we do see: light, rocks, stars, etc., matter around us. All the stuff we see is explained in terms of things we cannot see: subatomic particles, nuclear processes going on inside of stars, the core of the Earth, evolution on timescales that we cannot observe, the movement of tectonic plates, etc. And this is not unusual even in day-to-day life. As David says there, you might very well have this experience of being shot by an airgun. Well, if that happens and you see the pellet rolling away, it would be the best explanation that someone that you might never see, the unseen person, must exist in order for you to have experienced what you experienced. As David goes on to say, quote, "Clearly the theory of such a person's existence is not a logical consequence of the observed evidence, which, incidentally, would consist of a single observation, nor does that theory have the form of an inductive generalization. For example, that you will observe the same thing again if you perform the same experiment, nor is the theory experimentally testable. Experiment could never prove the absence of a hidden prankster. Despite all that, the argument in favour of the theory could be overwhelmingly convincing if it were the best explanation." Pausing there, my reflection. So this is what detectives and the legal system have to do all the time. What they're doing is trying to explain one-off events rather often. And when you have these one-off events, a particular murder, a particular assault, where you do not have the murderer or you do not have the criminal in custody, and you might not even know who the person is yet, nonetheless, the best explanation has to be that a person did it, that a particular person did this thing. But you can't arrive at that conclusion based upon any kind of inductive claim. It's not like you're going to be able to witness that same murder over and over again. You've got it only one time. You're witnessing it only once, and you will only ever witness it once. And there's no experiment that you can do in order to demonstrate that a particular person, did this murder. But rather, what we do is we gather evidence, and then the best explanation of the evidence, our conjectures, which all come to bear on trying to explain this evidence, are then set against one another in light of the evidence, and each of them ruled out until one of them, ideally, explains all the evidence. And no piece of evidence is able to rule out a particular murderer or criminal or whatever happens to be the case. So I guess what I'm saying there is, if you want another refutation of inductivism, then just look at how the legal system works. David goes on to say, quote, "Whenever I have used Dr. Johnson's criterion to argue for the reality of something, one attribute in particular has always been relevant, namely complexity. We prefer simpler explanations to more complex ones, and we prefer explanations that are capable of accounting for detail and complexity to explanations that can account only for simple aspects of phenomena. Dr. Johnson's criterion tells us to regard as real those complex entities which, if we did not regard them as real, would complicate our explanations. For instance, we must regard the planets as real because if we did not, we should be forced into complicated explanations of a cosmic planetarium, or of altered laws of physics, or of angels, or of whatever else would, under that assumption, be giving us the illusion that there are planets out there in space. Thus, The observed complexity in the structure or behavior of an entity is part of the evidence that that entity is real, but it is not sufficient evidence. We do not, for example, deem our reflections in a mirror to be real people. Of course, illusions themselves are real physical processes, but the illusory entities they show us need not be considered real because they derive their complexity from somewhere else. They are not autonomously complex. Why do we accept the mirror theory of reflections but reject the planetarium theory of the solar system? It is because, given a simple explanation of the action of mirrors, we can understand that nothing of what we see in them genuinely lies behind them. No further explanation is needed because the reflections, though complex, are not autonomous. Their complexity is merely borrowed from our side of the mirror. That is not so for planets. The theory that the cosmic planetarium is real and that nothing lies beyond it only makes the problem worse, for if we accepted it, then instead of asking only how the solar system works, we should first have to ask how the planetarium works, and then how the solar system it is displaying works. We could not avoid the latter question, and it is effectively a repetition of what we were trying to answer in the first place. Now we can rephrase Dr. Johnson's criterion thus: if, according to the simplest explanation, an entity is complex and autonomous, then that entity is real. Computational complexity theory is the branch of computer science that is concerned with what resources, such as time, memory capacity, or energy, are required to perform given classes of computations. The complexity of a piece of information is defined in terms of the computational resources, such as the length of the program, the number of computational steps, or the amount of memory that a computer would need if it was to reproduce that piece of information. Several different definitions of complexity are in use, each with its own domain of applicability. The exact definitions need not concern us here, but they are all based on the idea that a complex process is one that in effect presents us with the results of a substantial computation. The sense in which the motion of planets presents us with the results of a substantial computation is well illustrated by a planetarium. Consider a planetarium controlled by a computer, which calculates the exact image that the projectors should display to represent the night sky. To do this authentically, the computer has to use the formulae provided by astronomical theories. In fact, the computation is identical to the one that it would perform if it were calculating predictions of where an observatory should point its telescopes to see real planets and stars. What we mean by saying that the appearance of the planetarium is as complex as that of the night sky it depicts is that those two computations, one describing the night sky, the other describing the planetarium, are largely identical. So we can re-express Dr. Johnson's criterion again in terms of hypothetical computations. Quote, if a substantial amount of computation would be required to give us the illusion that a certain entity is real, then that entity is real. If Dr. Johnson's leg invariably rebounded when he extended it, then the source of his illusions, God, a virtual reality machine or whatever, would need to perform only a single computation to determine when to give him the rebounding sensation. Something like, if leg is extended, then rebound. But to reproduce what Dr. Johnson experienced in a realistic experiment, it would be necessary to take into account where the rock is, and whether Dr. Johnson's foot is going to hit or miss it, and how heavy, how hard, and how firmly lodged it is, and whether anyone else has just kicked it out of the way, and so on. A vast computation. Pausing there, my reflection. So, yes, this is the point. If you're trying to assert that what external reality appears to be isn't actually real, but rather it's an illusion, it's a dream, it's a deception by a demon or a god or something like that, then what you're saying is that those objects in the illusion, the dream rocks, the dream people, the dream planets, and so on and so forth, are acting in such a way that is so complex that if you were to get a computer to actually compute what is required in order to make the illusion as real as realism would otherwise seem, means that you have to compute precisely the laws of physics as they are under realism. Basically, if you're trying to create the illusion of a rock, you need to simulate a rock. And the higher the fidelity of the simulation of that rock, the more computation is required. And clearly, if you've got an illusion that has the fidelity of realism, then you're going to have to do a simulation that is of such high resolution that you may as well just fall back on realism. Realism is just all of that simulation without the needless extra assumption that it's all a simulation. But we might very well consider Where is this really an issue? Apart from in the hallowed halls of academia, in the ivory tower, debating about whether or not we're all living in a simulation or it's all a dream, does this really have any practical significance? Is it really a scientific question? Well, yes, of course it is. This is one of the motivations for the fabric of reality, is in trying to persuade people that there is a realistic way of looking at quantum theory. So, yes, because this has many antecedents. Okay, the classic one is, of course, Galileo. Galileo trying to convince the church that it wasn't just that we appeared to live in a universe where the sun was at the centre and the earth was orbiting the sun, but rather those appearances were reality. The explanation of the sun being at the centre and the earth going around the sun and the other planets going around the sun wasn't merely a convenient mathematical device for making predictions, it was reality. And so we come forward to today, where people deny the realistic conception of quantum theory. They deny the richness of what reality contains. But we need that richness, that complexity, that computational complexity, in order to be able to make the accurate predictions that we do make. Nowhere is this more clear than in the case of quantum theory. As David goes on to say in this very chapter, quote, "Physicists, trying to cling to a single universe worldview, sometimes try to explain quantum interference phenomena as follows. No shadow photons exist, they say, or in other words, no multiverse exists. And what carries the effect of the distance slits to the photon we see is nothing. Some sort of action at a distance, as in Newton's law of gravity, simply makes photons change course when a distance slit is opened. But there is nothing simple about this supposed action at a distance. The appropriate physical law would have to say that a photon is affected by distant objects exactly as if something were passing through the distant gaps and bouncing off the distant mirrors so as to intercept that photon at the right time and place. Calculating how a photon reacts to these different objects would require the same computational effort as working out the history of large numbers of shadow photons. The computation would have to work its way through a story of what each shadow photon does. It bounces off this, is stopped by that, and so on. Therefore, just as with Dr. Johnson's rock, and just as with Galileo's planets, a story that is in effect about shadow photons necessarily appears in any explanation of the observed effects. The irreducible complexity of that story makes it philosophically untenable to deny that the object exists." End quote. This is just my reflection here. Another way of putting this is that, well, when you look at the Schrödinger wave equation, which is a description of the position, for example, it doesn't have to be the position, it could be any of the other quantum properties that a particle or a system happens to have. It could be the velocities of these particles. But let's say in the simple case, we're just talking about, I don't know, the position of a single electron. Then what you have at some time t is a plot of all the positions that, in theory, actually in reality, but in theory, the electron is occupying. And you need to have all of these positions in order to be able to make some claim about how this electron is going to behave in the future. So what positions it could possibly occupy in the future, at some future time t. And so if you're going to make that prediction by calculating using the laws of quantum theory, you have to know what all the positions are now. And if all those positions come together now in order to affect future positions and future velocities of the electron, then in what sense aren't they real? Well, some people just deny that these are all real, and in fact, that all the possible positions that the electron could have at some point in the future, well, they all collapse, as we say. The collapse of the wave function happens upon measurement. And this is to deny the reality of all those other positions, and yet those other positions were required in order to make sensible claims about where the electron is now and where the electron might be found in the future. So this is the sense in which it is as computationally complex to either have a single universe theory or a many universes theory. The single universes theory simply says that all the entities required to take account of when you're computing what is going to happen from one moment to the next using the laws of quantum theory. All those entities are not real. The only ones that are real are the ones that you observe, so there's some special place for the observer. There's some special physics for the observer. And this is what the multiverse vision of quantum theory denies. It says there is no special dispensation, there is no special theory of physics for observers. There is one universal physics for everything, observers and non-observers. And hence, it's all real. All the things required in the computation, everything that makes these situations computationally complex, are real. But still, some people deny the reality of the things that we cannot see, which, as we've said in this podcast, as David says in both of his books over and over again, is a strange way of envisioning what science is. Science is the seen in terms of the unseen. As David goes on to say right now, quote, "The physicist David Bohm constructed a theory with predictions identical to those of quantum theory, in which a sort of wave accompanies every photon, washes over the entire barrier, passes through the slits, and interferes with the photon that we see. Bohm's theory is often presented as a single universe variant of quantum theory, but according to Dr. Johnson's criterion, that is a mistake. Working out what Bohm's invisible wave will do requires the same computations as working out what trillions of shadow photons will do. Some parts of the wave describe us, the observers, detecting and reacting to photons. Other parts of the wave describe other versions of us, reacting to photons in different positions. Bohm's modest nomenclature, referring to most of reality as a wave, does not change the fact that in his theory, reality consists of large sets of complex entities, each of which can perceive other entities in its own set, but can only indirectly perceive entities in other sets. These sets of entities are, in other words, parallel universes." Pausing there, my reflection. Yes, so Bohmian wave mechanics, this idea of David Bohm that there is this indivisible wave that passes through the slits, for example, that is accompanying any particle that we see, has an accompanying wave associated with it. Well, this wave is just the counterparts in the other universes of the particle that we see. And as David has said in other contexts, this is nothing but the multiverse in heavy disguise. Not even that heavy disguise, really. After all, if you were to have a God's eye view of the multiverse, and if you were to see what happens during a interference experiment, such as firing a supposed one electron at a double slit, then what you would see is something that looks like a wave. But that's just because the stupendously large amount of accompanying electrons in other universes, there's so many of them, that they appear to move, all when you take them all together, the entire ensemble of them, the entire set of them, or class of them, or however you want to describe them, appears to move kind of like a wave. It would kind of look like a wave. In higher dimensional space, it is a wave. And if you were to just glance at that wave, you might very well say, well, that's a wave. But then if you ask the question, what is that wave made out of? And you look closely at high resolution, you would see that the wave that appears to be there is actually made up of lots and lots of particles. It's made up of lots and lots of electrons that are accompanying the electron that any observer in any particular universe would observe as only being one electron. Let's continue. And David says, quote, "I have described Galileo's new conception of our relationship with external reality as a great methodological discovery. It gave us a new, reliable form of reasoning involving observational evidence. That is indeed one aspect of his discovery. Scientific reasoning is reliable, not in the sense that it certifies that any particular theory will survive unchanged, even until tomorrow, but in the sense that we are right to rely on it. For we are right to seek solutions to problems rather than sources of ultimate justification. Observational evidence is indeed evidence, not in the sense that any theory can be deduced, induced, or in any other way inferred from it, but in the sense that it can constitute a genuine reason for preferring one theory to another." Pausing there, just my reflection on that. So how can observational evidence cause us to prefer one theory over another? Well, simply by the fact that observational evidence tends to refute all other theories except for one. Ideally, this is what happens in science. We end up only with one theory being able to explain the observational evidence. So all of its rivals are no longer preferred. And this is the sense in which we say that it allows us to prefer one theory to another, or one theory to all the other rivals. The observational evidence simply rules out all the other rivals, can only be explained by one theory, one explanation that we have. To fall back on the most classic of all the examples that I use, Eddington's experiment, where starlight appears to be in one place rather than another, that one place that the starlight does appear during a solar eclipse is predicted by general relativity, but none of the other rivals. No other rival to general relativity can make that prediction in the way that general relativity does, and so therefore we prefer general relativity over those other theories. Let's continue. David says, quote, "But there is another side to Galileo's discovery which is much less often appreciated. The reliability of scientific reasoning is not just an attribute of us, of our knowledge and our relationship with reality, it is also a new fact about physical reality itself, a fact which Galileo expressed in the phrase, 'The book of nature is written in mathematical symbols.' As I have said, it is impossible, literally, to read any shred of a theory in nature. That is the inductivist mistake. But what is genuinely out there is evidence. Or more precisely, a reality that will respond with evidence if we interact appropriately with it. Given a shred of a theory, or rather shreds of several rival theories, the evidence is available out there to enable us to distinguish between them. Anyone can search for it, find it, and improve upon it if they take the trouble. They do not need authorization or initiation or holy texts. They need only be looking in the right way, with fertile problems and promising theories in mind. This open accessibility not only of evidence but of the whole mechanism of knowledge acquisition is a key attribute of Galileo's conception of reality. Galileo may have thought this self-evident, but it is not. It is a substantive assertion about what physical reality is like. Logically, reality need not have had this science-friendly property, but it does, and in abundance. Galileo's universe is saturated with evidence. Copernicus had assembled evidence for his heliocentric theory in Poland. Tycho Brahe had collected his evidence in Denmark, and Kepler in Germany. And by pointing his telescope at the skies over Italy, Galileo gained greater access to the same evidence. Every part of the Earth's surface, on every clear night, for billions of years, has been deluged with evidence about the facts and laws of astronomy. For many other sciences, evidence has similarly been on display to be viewed more clearly in modern times by microscopes and other instruments. Where evidence is not already physically present, we can bring it into existence with devices such as lasers and pierced barriers, devices which it is open to anyone, anywhere, at any time, to build. And the evidence will be the same regardless of who reveals it. The more fundamental a theory is, the more readily available is the evidence that bears upon it to those who know how to look, not just on Earth, but throughout the multiverse. Pausing there, my reflection on this. Isn't this a wonderfully positive, optimistic way of envisioning how to do science? It's open to anyone, anywhere, to make these profound discoveries, as David Deutsch says elsewhere. The evidence, in order to win a Nobel Prize, is here right now in this room, either falling from the sky in the form of light, or around you in the atoms out of which the matter is made, for you to make the discovery. That will lead to the next greatest breakthrough. That could lead to the Nobel Prize. What he says there is, where evidence is not already physically present, we can bring it into existence with devices such as lasers and pierced barriers, devices which it is open to anyone, anywhere, at any time, to build. Now, yes, building Large Hadron Colliders and James Webb Space Telescopes, yes, that's hard, that's expensive, but in principle, it's possible. And as wealth increases for everyone, this means it becomes more and more possible over time for people to have more and more sophisticated equipment to make the scientific breakthroughs that are required to solve the problems of the future. Everyone now just about carries around an extremely high-fidelity camera and a supercomputer in their pocket, which can do the kind of experimental work that people before could only dream of. The fact that so few people use them in order to actually do science, well, that's another issue. The fact is, science is an even playing field. It's as even as you like. And the cheap and readily available super technology that we have now in the form of smartphones and computers and that kind of thing means that even if there is a wealth inequality between people, that wealth inequality is actually decreasing over time. People talk about the increase in inequality, but that is usually only ever based on number of shares in a company held by someone like Elon Musk, who, happens to own one of the most profitable companies, or Jeff Bezos, who owns one of the most profitable companies. On the other hand, inequality has never been more narrow. Many of us own phones identical to Elon Musk. Elon Musk doesn't have or Jeff Bezos doesn't have better access to the day-to-day technology than anyone else does. This did not used to be the case, of course. You only have to go back 2 or 3 decades, and the top mobile phones that were available were well out of the reach of the average person. Now the top mobile phone, as I'm recording this, it's like the iPhone 13 Pro or whatever. That is well within the budget of many, many people. So too for the top desktop computers, and so on and so forth. And all of this is to say that the typical person has access to technology, which, directed towards scientific discovery, could indeed make breakthroughs that people of the past could only have dreamed of, and to solve problems, even outstanding problems today. Routinely, amateur astronomers make discoveries of things like comets, and even today, exoplanets, just by looking at published data on the internet that's freely available and processing it. So the evidence is absolutely available to everyone in order to make these discoveries, to solve some of our most pressing problems. David goes on to say, quote, "Thus, physical reality is self-similar on several levels. Among the stupendous complexities of the universe and multiverse, some patterns are nevertheless endlessly repeated. Earth and Jupiter are in many ways dramatically dissimilar planets, but they both move in ellipses, and they are both made of the same set of 100 or so chemical elements, albeit in different proportions, and so are their parallel universe counterparts. The evidence that so impressed Galileo and his contemporaries also exists on other planets and in distant galaxies. The evidence being considered at this moment by physicists and astronomers would also have been available 1 billion years ago, and will still be available 1 billion years hence. The very existence of general explanatory theories implies that disparate objects and events are physically alike in some ways. The light reaching us from distant galaxies is, after all, only light, but it looks to us like galaxies. Thus, reality contains not only evidence but also the means, such as our minds and our artifacts, of understanding it. There are mathematical symbols in physical reality. The fact that it is we who put them there does not make them any less physical. In those symbols, in our planetariums, books, films, and computer memories, and in our brains, there are images of physical reality at large. Images not just of the appearance of objects, but of the structure of reality. There are laws and explanations, reductive and emergent. There are descriptions and explanations of the Big Bang and of subnuclear particles and processes. There are mathematical abstractions, fiction, art, morality, shadow photons, parallel universes, to the extent that these symbols, images, and theories are true, that is, they resemble in appropriate respects the concrete or abstract things they refer to, their existence gives reality a new sort of self-similarity, the self-similarity we call knowledge. And that there is the end of Chapter 4 of The Fabric of Reality, Criteria for Reality. And I want to note here, just at the end there, that powerful way of ending echoes what is said by David in one of his TED Talks, where he talks about this kind of self-similarity, when he talks about the quasar. The most important kind of self-similarity is the self-similarity of what happens inside of our minds, where we try to understand objects in our world, including things like quasars. What happens over time, this special relationship we have with the laws of physics, means that there can be an object like a quasar with physics as violent and unusual as is going on in a quasar, and that physics we can come to understand. And so we can come to build not merely, as David says, a visual representation of what the quasar looks like in our mind, so we can see it in our mind's eye, but also we can have mathematical relationships. We can come to understand the laws, the physical laws expressed in mathematical relationships and expressed in natural language in our minds as well. And over time, our explanation, our model of that quasar comes to represent the real quasar existing out there in physical reality with greater and greater fidelity over time. The two structures, the model that's going on inside of our minds and the physical thing out there billions of light years away, come to resemble one another more and more accurately over time. This is self-similarity. This is the most important kind of self-similarity that we know of, because it implies everything that we've been talking about here. It implies realism. It implies that this explanation, this objective explanation that is being built over time, error-corrected over time in our minds, conjectured over time in our minds and error-corrected, is coming to more accurately represent the reality, the physical reality that's out there. And this final paragraph also, it is a defense of realism. It's also, I would say, an improvement on Popper. So let's go to that now. Let's have a look at what Popper actually said in Objective Knowledge about common sense and realism, just briefly. And I'm looking at page 37. If anyone wants to read along, this is page 37 of Objective Knowledge. He says, realism is essential to common sense. Common sense, or enlightened common sense, distinguishes between appearance and reality. This may be illustrated by examples such as, today the air is so clear that the mountains appear so much nearer than they really are. Or perhaps, he appears to do it without effort, but he has confessed to me that the tension is almost unbearable. But common sense also realizes that appearances, say a reflection in a looking glass, have a sort of reality. In other words, that there can be a surface reality, that is, an appearance, and a depth reality. Moreover, there are many sorts of real things. And then Popper goes on to list a whole bunch of real things. So I'll skip over that and we'll go to Popper's arguments for realism that he comes to. He says, quote from Popper, "My thesis is that realism is neither demonstrable nor refutable. Realism, like anything else outside logic and finite arithmetic, is not demonstrable, but while empirical scientific theories are refutable, realism is not even refutable." Now, I would say here, and here is me translating Popper, and I could be getting this wrong, when he uses the word refutation here, what he's talking about is experimental falsification. Of course, we can refute realism, or we can refute any other philosophical theory that we like by means of philosophical argument. Now, we'll fail to do so in the case of realism, but it doesn't mean we can't say, hey, that's wrong because here's my argument that the simulation hypothesis is correct. So I'm refuting realism. I'm not successful in my refutation, but I'm attempting to refute it. Or it could also mean that Popper is saying that there's simply no way that any argument can possibly refute realism or possibly show that realism is wrong. I don't think he would go that far. After all, we're fallible, and so making a categorical claim like it's impossible to even show a flaw with realism can't possibly be the case. Anyway, whatever the case, he goes on to say that realism, not being refutable, shares this irrefutability with many philosophical or metaphysical theories, in particular also with idealism. Yes, so there we have it. So he must be saying there that all of these metaphysical theories, idealism or whatever else, the simulation hypothesis, are not experimentally testable or experimentally falsifiable, and he's identifying that with refutability. It could be the case that he's simply wrong as well, and as David has pointed out in The Fabric of Reality, well, we can refute idealism. How? Well, by talking about the sheer amount of computation required in order to generate an idealistic conception of the world. If you take seriously what idealism is, then you would need to have some means of computing where all of the objects in your dream world happen to be, and that would amount to computing what's really going on in the world. And so therefore we have realism. So there's all sorts of ways of coming at this refutation of things that aren't realism. So that very well could be a simple improvement on Popper, because he goes on straight away to say, but it is arguable, and the weight of the arguments is overwhelmingly in its favour. Okay, so, end quote. So this is a poor phrasing, I would say, of Popper. The weight of the arguments. Okay, so we don't endorse this idea that we have weight of arguments. Better to say, so if he's just saying good explanation is what David would say, presumably, the way in which to really come at this is to say that we refute idealism because it's a bad explanation, rather than talking about weight of arguments. We can argue for realism because it is the best explanation of our metaphysical ontology, if we want to use the fancy words. But that's the fact of the matter. Our best explanation, the most parsimonious way of viewing our experience of the world, is that it really exists. There's an external reality out there beyond our dreaming, beyond our being inside of a simulation or anything else like that. Popper goes on to say, quote, "Common sense is on the side of realism. There are, of course, even before Descartes, a few hints of doubt, whether or not our ordinary world is perhaps just a dream. But even Descartes and Locke were realists. A philosophical theory competing with realism did not seriously start before Berkeley, Hume and Kant. Kant, incidentally, even provided a proof for realism, but it was not a valid proof, and I think it important that we should be clear why no valid proof of realism can exist. End quote. Quite right. Okay, we can't, and we don't need to. The proof is not the most important thing unless you are someone who subscribes to the hierarchy that David talks about in The Fabric of Reality, in the chapter I just read, where mathematical proof, mathematics, the certainty that one supposedly gets with mathematics, is the gold standard against which all other claims to truth must be measured. And the only thing that sort of gets anywhere near that is scientific confidence, that we have these arguments where we collect the evidence and we become highly confident in our scientific claims, whereas philosophy is a mere matter of taste. So we don't need to worry about the fact there's no valid proof for realism. There's no scientific evidence for realism. We have a robust explanation of realism, a philosophically rigorous argument that explains why realism is correct. So what does Popper say about idealism? Well, he says, quote, "In its simplest form, idealism says, the world, which includes my present audience, is just a dream. Now it is clear that this theory, though you will know it is false, is not refutable. Whatever you, my audience, may do to convince me of your reality, talking to me or writing a letter, or perhaps kicking me, it cannot possibly assume the force of a refutation. For I would continue to say that I am dreaming, that you are talking to me, or that I received a letter or felt a kick. One might say that these answers are all, in various ways, immunizing stratagems. That is so, and it is a strong argument against idealism. But again, that it is a self-immunizing theory does not refute it." So we can see there that clearly what he means by refutation is experimental falsification, rather than refutation by it being a bad explanation, or rejecting it because it's a bad explanation. And he continues, quote, "Thus, idealism is irrefutable, and this means, of course, that realism is indemonstrable. But I am prepared to concede that realism is not only indemonstrable, but, like idealism, irrefutable also. That no describable event and no conceivable experience can be taken as an effective refutation of realism. Thus, there will be in this issue, as in so many, no conclusive argument, but there are arguments in favour of realism, or rather against idealism." And now Popper goes on to list his arguments against idealism, or for realism if you like. 1. Perhaps the strongest argument consists of a combination of two: A, that realism is part of common sense, and B, that all the alleged arguments against it are not only philosophical in the most derogatory sense of this term, but are at the same time based upon an uncritically accepted part of common sense, that is to say, upon that mistaken part of the common sense theory of knowledge which I have called the bucket theory of mind. And 2, although science is a bit out of fashion today with some people, for reasons which are, regrettably, far from negligible, we should not ignore its relevance to realism, despite the fact that there are scientists who are not realists, such as Ernst Mach, or in our own lifetime, Eugene Wigner. Their arguments fall very clearly in the class just characterised in 1b. Let us here forget about Wigner's argument from atomic physics. We can then assert that almost all, if not all, physical, chemical, or biological theories imply realism, in the sense that if they are true, realism must also be true. This is one of the reasons why some people speak of scientific realism. It is quite a good reason. Because of its apparent lack of testability, I myself happen to prefer to call realism metaphysical rather than scientific. However one may look at this, there are excellent reasons for saying that what we attempt in science is to describe, and so far as possible, explain reality. We do so with the help of conjectural theories, that is, theories which we hope are true or near the truth, but which we cannot establish as certain or even as probable in the sense of a probability calculus, even though they are the best theories which we are able to produce and may therefore be called probable as long as this term is kept free from any association with the calculus of probability. There is a closely related and excellent sense in which we can speak of scientific realism. The procedure we adopt may lead, as long as it does not break down, for example because of anti-rational attitudes, to success in the sense that our conjectural theories tend progressively to come nearer to the truth, that is, to true descriptions of certain facts or aspects of reality. And then Popper goes on to make some more remarks about realism, but I'm going to pick it up. I'm going to skip that and pick it up where he says, quote, "To me, idealism appears absurd, for it also implies something like this, that it is my mind which creates this beautiful world. but I know I am not its creator. After all, the famous remark, beauty is in the eye of the beholder, though perhaps not an utterly stupid remark, means no more than that there is a problem of the appreciation of beauty. I know that the beauty of Rembrandt's self-portrait is not in my eye, nor that of Bach's passion in my ear. On the contrary, I can establish to my satisfaction by opening and closing my eyes and ears that my eyes and ears are not good enough to take in all the beauty that is there. Moreover, there are people who are better judges, better able than I to appreciate the beauty of pictures and music. Denying realism amounts to megalomania, the most widespread occupational disease of the professional philosopher. That's great. End quote. So there, Popper is actually getting at, he's hinting at what David says, using different language, of course, that the inner workings of the mind of the supposed idealist would have to be as complex as what realism actually is, okay? It would contain all of this complexity. And he goes on to say, quote, "Out of many other weighty though inconclusive arguments, I wish to mention only one. It is this: if realism is true, more especially something approaching scientific realism, then the reason for the impossibility of proving it is obvious. The reason is that our subjective knowledge, even perceptual knowledge, consists of dispositions to act and is thus a kind of tentative adaptation to reality, and that we are its searchers at best, and at any rate fallible. There is no guarantee against error. At the same time, the whole question of the truth and falsity of our opinions and theories clearly becomes pointless if there is no reality, only dreams or illusions. To sum up, I propose to accept realism as the only sensible hypothesis and as a conjecture to which no sensible alternative has ever been offered. I do not wish to be dogmatic about this issue any more than about any other, but I think I know all the epistemological arguments. They are mainly subjectivist, which have been offered in favour of alternatives to realism, such as positivism, idealism, phenomenalism, phenomenology, and so on. And although I am not an enemy of the discussion of isms in philosophy, I regard all the philosophical arguments which, to my knowledge, have ever been offered in favour of my list of isms are clearly mistaken. Most of them are the result of a mistaken quest for certainty or for secure foundations on which to build, and all of them are typical philosophers' mistakes in the worst sense of the term. They are all derivatives of a mistaken, though commonsensical theory of knowledge which does not stand up to any serious criticism. Pausing there, my reflection. That's wonderful there, okay? That is a wonderful philosophical refutation of all of those isms he talks about and a defense of realism. All of these alternatives, idealism chief among them and its cousins, what Popper is saying there is that the only motivation that anyone has for putting them forward in the first place is because they want a secure foundation. They're relying on the justified true belief conception of knowledge. They don't believe in conjectural knowledge in the first place. They want to know, okay, in the case of modern variants like the simulation hypothesis, why postulate it? Well, so that you can have some way of saying, well, this is absolutely certainly the case. This is certainly what our ultimate reality consists of. It's simulations inside of simulations inside of simulations. Now I'm justified in my belief that realism, naive realism, is not the case, is not true. But if you're a Popperian, if you're a fallibilist, then you just say, well, there's no way of being certain about any of this. But it's a good working hypothesis just to say that we know that realism is the case and we can come to know that external physical reality that really exists better and better over time, never with certainty. But it's a good way, it's a good place to start on the assumption that realism is true. So I'll end it there for today. And just to notice that people have asked me, I think in my Ask Me Anything episodes, where David has improved upon Popper, and I gave a few indications of where I thought David had improved on Popper. Well, here's another one, okay, in this defense of realism. This defense of realism, I think the most parsimonious way of defending realism is to say it's the best explanation. All these other ways of trying to come at the ultimate metaphysical ontology, what really truly is the case when it comes to the experience we find ourselves in, the reason why idealism fails to be the best explanation is because it ultimately is realism with the additional philosophical assumption that we're just dreaming realism into existence. And I think David has the best way of explaining what it means for something to exist or what it means for something to be real in The Beginning of Infinity, where he says a thing is real or a thing exists insofar as it appears in our best explanations of reality and not otherwise. That's how we know, that's how we can conclude a thing exists. So that's the end of the episode today. If you'd like to become a Patreon supporter, please feel free. You can search for that on Google. Okay, just search for Patreon Topcast or Patreon Brett Hall. But until next time, bye-bye.